Everybody, we got an awesome question regards Gauss, and I really want to point out in this question that A, who is A? Remember, we have Gauss's law, which is the flux, right? Flux E dot dA equal to what? 2
in A
Q in A
divided by
divide, yes. And how I remember this equation? The first letter of Gauss is
geometry.
G. I need to take care of geometry. Don't forget this is a closed area. Closed area means if I'm gonna inject some water inside, they don't have where to go. They stuck inside. Glass is not a closed area, right? Because I can inject water and pour it out. A cube, closed cube, it is. A sphere, it is. I can inject, nothing gonna go out, right? So that's the idea. So geometry. And what is the last letter of binomial? What is the last letter of Gauss's? S, which means sum of charge. To sum all the charge where? Inside this area. If I choose a sphere, inside a sphere. If I choose rectangular, inside a rectangular. Note what happened at the neighbors. In the neighbors in the other city, I don't care. I care only the stuff inside the box. Perfect. So, to the question. The question is that I want to emphasize that this area is not real. That's the idea of the question, okay? So I have my nice space, okay? Space is divided to x, y, and if I draw it in that direction, it must be that z is actually pointing in that direction, okay? Right Cartesian coordinates. Okay? And I have this imaginary box. This is the imaginary box that I have. I have a box. Go like this, like this, like this. Is this box is real?
No,
It's not real. It's inside my head. It's my dA and my A and my area of this A. This I decided right now for this question that this area is going to be a box. Okay? That's what I need to decide. Can you close the door? Thank you. Okay? Perfect. So now I also know what it's given. It's given that the electric field in space. I don't know who is the motherfucker that created this electric field. I don't know. But I know that it's equal to that. When y is smaller than a over 2, my value is minus sigma divided by 2 epsilon node at the y direction. And when my y is in between 3, 4a and a over 2, its value is actually minus 3 sigma 2 epsilon node at the y direction. And when I am actually bigger than 3a4, its magnitude is sigma 2 epsilon 0 y. What you can say about this electric field?
it's variable.
It's what?
Variable. It changes.
It's changing. It's what else? It's ugly. It's not nice. But what we do know?
Direction.
Points and y.
We know its directions, okay? So we know the electric field and we know its direction. So this is a little bit Gauss feeling. I know directions, I know the geometry, I can use Gauss. What I really want to do with Gauss, I want to have an A that I can take this dot. What is this dot is actually is? Dot is from?
Kill vector.
Kill vector, or dot B, die vector. In Hebrew, die is also stop. Die vector. That's how I see dot. Okay, so dot actually taking, if I have E dot dA vector, is equal to the size. Size of them multiplied by cosinus alpha, and alpha is the angle between these two vectors. If this is E, this is dA, what is the angle between them? Okay? That's the thing. It's killing the vector. This is a scalar, not a vector. Okay? Perfect. So, they asked me wrong. Knowing that this is the electric field, what is the charge inside the cube? Only inside the cube. Can you tell me what is the charge? This is the definition of Gauss's law, okay? Gauss's law said, take imaginary thing, okay? If you can calculate this side, I for sure promise you, it's equal to the charge inside. I don't know what's going on inside. I don't know how crazy the party there is, what's going on, how the charge is distributed, but I can tell you for sure what is the total charge inside this imaginary box. Understood till now? Perfect. So let's solve the problem, okay? We have E, we have E, we have A. We just need to do it, right? So if I have a box in the integral, what we said about the integral, what's really fun with summation? 4 equal to 1 plus 1 plus 1 plus 1, right? This is all. Same thing with the area. If I sum up the A's, I can open the box, right? I can divide it to some regions and solve the equation for each region, right? So I'm moving to the other side. Please follow me. Camera people, thank you. Special thank you to the people with the camera and the people that are helping me translate. Thank you so much, you're helping the class. So I have this integral and I have this box, okay? E dot dA. What I can do to the box, I can open it, right? Let's open it to 6 walls, right? E wall, right? We have many E walls, dA, plus we have, not 6, 4. We have 4 walls, and we have also
2.
we have a roof and we have a floor. We have a roof and we have a floor. Do you see it?
Yes.
Roof and floor. We can do it, right?
Yeah.
It's okay. E roof dA plus E floor. What I really want you to notice, is you see that the closed sign of the integral? What's happened when I open the integral? It's not anymore closed surface, okay? The semantic. You see it? It's not a closed. If I'm taking a box, this box, let's go on to box. This box is a closed area, you see it? If I'm gonna inject water, they're gonna be stuck inside. But if I'm gonna cut it, now I look at what? At the side, the roof, at
Just
the floor. If I'm gonna put water here, it's an open, right? It's open. It's an open area. Perfect. So now what we need to do, we know E, right? Let's try to understand dA. Okay? Let's observe it. Where is E heading?
Y direction.
Camera, please.
Yeah.
Michael Jackson.
Yeah.
Okay? Where E is heading? Only at the Y direction.
Right.
Y direction every time.
No, that is ZU.
Only at Y.
No, that's
Also here, also here.
Wrong.
You see it?
it's the other
That is
direction.
Z. Y is up.
Sorry. Thank you. Thank you. So Y is actually pointing that way. Pointing that way, that way, that way, that way, that way, that way. You see it? dA. For that side, for the roof, where is pointing?
The
0.
same direction.
How we do dA? Remind you, dA
Radial.
is taking the sphere and starting to draw smileys, right? The nose, it's a known one. It shows where is dA heading. This one is here, and what is this one? This dA is in this direction, right?
90. Yeah.
Okay, so I see here that the angle is
0.
0. So I can go back, camera. So when I look at the roof, I can say that this one is actually the size E. At which location? I didn't say, but the size of the box are A by A. Okay?
Should I go back?
No. The sizes of the box are A. Okay? A by A by A. So this is E. At what location?
Y.
Y equal A, right? It's only one value of electric field. Okay, Y equal A. And we have dA, and we have a cosines to be
0.
0, which mean equal 1. Sorry, 0, which mean equal 1. What happened to the walls? Let's go back to the walls. Okay, I didn't draw it, but this point is, this one is the region, this one is A, 0, 0, this one is 0, 0, A, and this one point is, it's like A on A cube. Okay, and this one is 0, A, 0. What's happened to the walls? Electric field, this is the box, okay? This is the box. So, this is not a cube, right? It should be a cube. dA, smiley, right? Smiley. Pointing that way. And the electric field pointing that way. This wall, dA, electric field, only at the Y. This wall, dA, electric field, pointing that way. 90 degrees. Cosines of 90 degrees is
0.
0. Let's go back to the board. So this one is actually integral of E at many places. Crazy places. Okay? Think about the wall. The wall, you have X, Y, and Z, different rotation on the walls. dA, cosines, pi over 2. Dying out. We don't need it. Yes? Now, we have the floor. What's happening in the floor?
It's the same as the roof.
It's E equal what? 0. dA.
Cosine of
And the
0.
cosines is what?
0.
Not 0.
Wait, pi, it's pi.
It's pi. Thank you. It's pi, which means
Negative.
negative 1. It's not that bad, right? It's okay. Negative 1, we can deal with it. So, the area that was given, the box, was make sense. Yes, we got it?
Yep.
So, what we can do with these constants? What is this dA, actually? What's present? What's present the roof? What's present the roof?
The side square. Like,
If I have this box, let's say go back to this drawing. If I have the box and I want to discrete it to many areas, what is the size of this area?
dA.
It's dA, and it consists of some contribution
D small
in
a.
dz and some contribution at dx, right?
But since like the side is A, we can just take it as like D small a.
What?
The sides of the small cubes, which we take with that.
What are you talking about?
Like, since the side of the cube is A, so the small.
Ah, you said that all this area is equal to a square?
No, like
What?
when we take the small part of that one you took, can we just take it as D small a?
Yeah, this is dA. I just want to say, let's go there. I just want to say that this dA is actually dx multiplied by dy. That's all I want to say.
Oh,
Got me?
yes.
Perfect. So this one is this one. This one is the same as this one, right? And this E is a constant, right? At y equal a, y equals 0. What we know the electric field is, thank you Ben, we know that it's changing only at y. So it's actually, each one of them is a constant. So let's found it. So this one is actually equal to what? EY equal a, it's bigger than that.
Yeah.
So
that's
it's
sigma.
this. So this one is equal sigma 2 epsilon naught plus at the y direction dot dx
dy.
dz, not y.
Dz.
Also at the y direction, right?
Yes.
Right? And this one actually killing themselves in the same direction, and there's an integral, right? So if we're going to sum all the dx and the dz, it's actually, it's from 0 to a, it's from 0 to a, it's actually a squared.
A squared.
So this is a squared sigma 2 epsilon 0, right? This was the roof, right? Plus, we have this contribution. I'm going to do this separation. So what is EY0?
Negative sigma to epsilon.
We have negative sigma. Yes. Help me.
To epsilon.
Yes.
Y
Y
cap
direction. Perfect.
times
It's
d
negative again.
dz dx.
dz dx at
Y.
Minus
Y.
y.
No, it's negative y.
perfect
Yeah.
negative y. Okay. So these two minuses actually killing each other out. So this one is a squared sigma 2 epsilon 0, right? By the way, this is a question for exam.
Well,
This is a question for exam. Okay? Okay, so we're going to sum this one and this one, and we have our final result. Right?
yeah.
No,
No, wait.
you asked for the charge.
Huh? Good. We didn't finish. Gauss's law, what Gauss's law said, cameraman? What Gauss's law said, if you found this thing, we can find this thing, right?
Right.
So let's finish the question. We don't need the electric field anymore. Okay? We want this thing, so we know that this one is actually equal to a squared sigma divided by epsilon squared,
Epsilon.
right? Equal to q in a, epsilon squared, cancel, found it. Yes?
Yeah.
Now I want to ask you a question. Did you care what was the what make the electric field? We didn't need that. We just wanted to know what is the electric field. So I'm going to tell you that if you want to check it out, so if you're going to do this thing we have here, but let's do it the same way it was. Here it is. If you're going to have this is y, this is x, this is z, and we're going to put here at the height a over 2 charge of minus sigma, and we're going to put here at a 3 over 4a another infinite plane with the charge minus 2, plus 2 sigma. Okay? You're going to actually get, by superposition, the electric field that was before. You would not aware what made the electric field. You just know that Gauss's law hold. Understand? If you know, I can make this question harder. I can give you this, find the electric field, fine, and then ask you what is the charge. But actually it was a really easy question, because what you can do, you can do the box, say how much charge you're actually taking, right? You understand? Sum it up, say Q total equal to what? To the whole charge. And you said that you have contribution from each plate, right? You have sigma dA upper plate, sigma dA lower plate, and you just found it, you would find Q in A, okay? So equivalent question could go in that way. But without know what producing the charge, you can come with a device, measuring the electric field. I don't know what's going on, and I can tell you what is the charge that we have in this area, inside. Understand how strong tool it is? In biology, in chemistry, okay? Finding medicines, do devices. Gauss's law is an amazing tool that makes stuff easy for us, okay? So what I encourage you to do is go to the homework, do as much as Gauss's as you can, get this tool, okay? Get it in your pocket, okay? Because we're gonna need it. Every time right now, we're gonna try to find electric field, Gauss gonna be our favorable decision, okay? Got it?
Yeah.
Thank you very much, guys. Enjoy your weekend. Close the camera. Hope this lesson helped you.
Thank you.